problem. Find the Fourier transform of f of x equals a squared minus x squared when mod x is less than a, mod x is greater than a. As usual, the limits can be simplified as this. Okay, we know already the technique behind, we have already seen in the previous problem. So a squared minus x squared during this interval, x lies between minus a and plus a. We will have to use, otherwise it is 0. We will have to use Fourier transform formula. So Fourier transform is given by this formula. You are going to substitute f of x, you are going to substitute a squared minus x squared in this interval and 0 in this interval. As usual, we will have 3 terms. We have 3 terms now. Okay, so this term is 0, the last term also 0. You have center term. The limit lies between minus a and plus a. Your f of x is nothing but a squared minus x squared. Okay, a squared minus x squared. So the integration becomes 1 divided by 2 pi minus a to plus a squared minus x squared e power isx dx. Now you are going to integrate this. As usual, you will have to use only Bernoulli's formula. So this is your Bernoulli's formula. Okay, so here e power isx dx is nothing but dv. Your dv is e power isx dx is nothing but your dv. How to find out v? Integrate on both sides. Will give you v which is equal to e power isx divided by is. See, this is your v. This is the first term. This will be your first term, uv term. So you have u is here, your v is here, dv is here. You have to integrate and get the value for v. So v is nothing but isx by is. How to find the next term? As I said, you have to differentiate this term. When I am going to differentiate this term, that will give you minus 2x. Here one minus is there, the next term will be plus. Next term will be minus, the next term will be plus. Alternative plus and minus. Okay, so you have minus, just differentiate, that will give you minus 2x. You will have to integrate as I said. So already e power isx divided by is is there. After integrating, there will be another is, so that will become I squared a squared. Now again you have to differentiate, so that will give me minus 2. Then this term will be e power isx divided by 1, already I squared a squared is there. You have to multiply with is, so that will give me I cube s cube. What is the next term? It will be 0. So you can't differentiate. So we have 3 terms now. So for series, we will always go with Bernoulli's formula. Now, so we have integrated now, we will have to substitute the limits now. So substitute the limits, that will give you a squared minus x squared. We have simplified. This term is here. Okay, this term is here. Minus minus plus. I squared is minus 1. So we written minus 2x. E power isx divided by s squared. Okay. And this term, what about I cube? I cube can be written as I squared multiplied by I. I squared is minus 1. So minus I. Correct? Minus I. So you will get minus minus plus 2 e power isx divided by is cube from minus a to plus a. Now you are going to substitute the limit now. Is it okay? Anyone? So x squared can be replaced with a squared. A squared. So x squared is replaced with a squared. E power isa divided by is minus, we have substituted the upper limit, minus, we have substituted the lower limit for all the 3 terms. And this term is 0. This term also will be 0. The first 2 terms in the next expression, that will be 0. So you are going to have this term first. So this term first. And the next term is here. This is 0. And the next term is here. And next term is here with the minus sign is there. So minus plus minus, minus plus minus. So we have now 4 terms. Any doubt? Okay. Now as usual, as I said, you just pull s squared terms out, then s cube terms out. So s squared terms out, that will give you minus 2a by s squared. Remaining term will be e power isa. Here you have e power minus isa. So minus sign we have pulled out. So this will become plus. Okay. Then what are the remaining term? You have 2 divided by is cube. This term and the last term we have written exactly. So this can be replaced with cos term. This can be replaced with sin term. That's the idea. See, replaced with cos term and sin term. So now this is s cube is there. Okay. This side will cancel. 2 2s are 4. You can pull 4 out. Then remaining term just multiply and divide by s. So that will give you common term s cube. So this will become as cos 3a. This will become as it is sin 3a. So we can write this expression as sin 3a minus as cos sa divided by s cube. Okay, with a multiplication of 4 divided by root 2 pi. So this is the final answer. Any doubt? So now we will go for the next problem. F of x equals 1, your mod x is less than or equal to a, 0 otherwise. Okay, and very important thing is we are going to evaluate. So this is a somewhat tedious problem. We are going to evaluate this and this. We are going to find out the value of this and this after getting the answer for the Fourier transform of the function. Okay, so we are going to find the Fourier transform. We are going to use the answer to evaluate this and this. Is it okay? We will find out. So Fourier transform of f of x is given by f of s equals 1 divided by root 2 pi minus into plus infinity f of x equals e power isx dx. Okay. What is the interval? We know already the interval x lies between minus a and plus a. Otherwise it is 0. As usual we have 3 terms now. So the first term will be 0. The last term also will become 0. You are going to have only second term alone. So here one trick is there. We will see 1 divided by root of 2 pi f of x e power isx dx, which is equal to f of x is given as 1. So you have e power isx dx alone. E power isx can be expanded in terms of cos and cosine. We know already e power I theta. Can you remember? Similarly, this can be expanded in terms of cos and sine. Just to separate it. You can write separately. You can write. So this is here and this will be here. Another very important thing. Instead of integrating, we can go in a shortcut if we know even and odd function. The technique of even and odd function is very simple. Suppose f of x equals, you replace x with minus. If f of x equals minus or f of minus x, what we call this as odd function. If f of x equals f of minus x, you are going to replace x with minus x, the answer is plus itself, plus. Then we say that this function is nothing but even function. The first one is odd function, second one is even function. For example, you just take, we learnt already in mathematics earlier, cos of minus theta, sine of minus theta. Can you remember what is the answer? Cos of minus theta equals plus cos theta. Sine of minus theta equal to minus sine theta. So similarly something like that. So we have this, the condition for odd function, this condition for the even function. Instead of integrating, just use this method. Okay, now sine 3s, this is odd function. Just now I said sine of minus theta equals minus sine theta. It is an odd function. For all odd function during this interval minus a to plus a, the answer is 0. You remember. Instead of integrating, if you integrate also the answer will become 0. Okay, when you are going to integrate, the answer surely will be 0. But instead of integrating, you can have the shortcut if you know odd function and even function properly. I repeat, sine minus theta equals minus sine theta. So during this interval, minus a to plus a. So this is an odd function. For all odd function, answer is 0. So this will become 0. What if this cos x in this interval minus a to plus a? This is even function. We can integrate. Doesn't matter. We can integrate. So we have now cos x dx. This is an even function. For even function, you can write this as twice of 0 to a. This is minus a to plus a. For the even function, you can write 2 times of 0 to a, not for the odd function. Is it okay? For the even function, look at the limit here, minus a to plus a. For the even function, you can write this as 2 times of 0 to a. So this can be written as 2 divided by root 2 pi cos x dx. Now integrate. Cos x will give you sin x divided by s. So 2 divided by 2 pi, apply the limits, you will get this. 2 divided by 2 pi multiplied by times sin sa by s. So this is the required Fourier transform of the function. Now we have found out only one part. We have found out the Fourier transform of this. We will have to evaluate this and this. Correct? We will have to evaluate. So you remember this one, f of s, we have obtained f of s. Okay? You remember this one. Now Fourier inverse transform is given by. So we know we have used now the second formula, f of x equals 1 divided by root 2 pi minus plus infinity capital F of s e power minus isx ds. This is for the inverse Fourier transform. Now already we found out f of s. So this is your f of s. You substitute here. Okay, we have already found this f of s, capital F of s we have found out. You substitute in this expression. Okay, this is f of x, correct? F of x equal to, what is the given f of x equal to? So we can write this expression as f of x equals in this interval. Is it okay? This is your f of x. You have substituted for the answer which you have found out earlier, capital F of s. And f of x equal to this one. So we can compare these two. During this interval, this will act. Okay, now, first x equal to 0. We will go for x equal to 0. When x equal to 0, this term, 1 by e power isx, that will become 1. E power 0 is 1. Anything to the power 0 is 1. So this term will go off. You will have only this term alone. See, I have written this term alone. I have pulled this 2 divided by 2 pi out. So minus into plus infinity sin sa by s ds, which is equal to 1 here. Okay, which is equal to 1. So which is equal to 1. Is it okay? Now, what is this function? Sin sa, odd function or even function? Sin sa. Very good. Sin sa is odd function. One s is in the denominator now. C is correct. See, sin sa alone is an odd function. Now s is in the denominator. This will become minus. This will become minus. They will get cancelled. Sin sa by s is nothing but even function. Is it okay? So if you understand very well, it's very simple, very easy. Sin sa is odd function. Whereas sin sa divided by s, you have to replace this by minus s. Correct? Instead of s, you have to replace minus s. So this will become minus sin sa divided by minus s. That minus, this minus will cancel. And sin sa divided by s is nothing but your even function. If it is even function, you can write the limit as twice. Just now I said. For the odd function, you can't write. Whereas for the even function, you can write this as twice. Easy to integrate. So instead of minus m to plus infinity, you can write this as 2 times 0 to infinity sin sa by s ds, which is equal to, this is 2 will get cancelled. Pi is 1 by pi. I have brought this pi here, which is nothing but your pi. So what is the answer? Sin sa by s ds integration, that will give you pi by 2. So this is the problem that it is asked. See, sin s divided by s ds, which is nothing but your pi by 2. Which is nothing but your pi by 2. Any doubt? Okay, now we will go for the second division using inverse transform. So f of x equals 1 divided by root 2 pi minus into plus infinity capital F of s e power isx ds. Now f of s is given by this. Correct? Your f of s already we have found out, Fourier transform of the given function. We have found out this. So we have substituted. E power is can be expanded in terms of sine and cosine. So cos sx minus I sin sx. You multiply this by this minus this by this. Separate the terms. So separate the terms. Left hand side is nothing but f of x. F of x is nothing but your 1 and 0. So there are given values. Okay, now you compare this and this. You have to compare this by real with real, imaginary part with imaginary part. There is no imaginary part here. So this term will become 0. Okay, there is no imaginary part here. Only real term alone exists. So this term must be equal to 1 here. So this term is equal to here. Is it okay? Now this one, 2 you just pull it out. 2 pi multiplied 2 pi will give you 2 divided by 2 pi. These 2 and that 2 will cancel. Okay, these 2. You have 1 pi by pi alone. You just bring 1 by pi to this side, you will have pi. So this was asked. Evaluate this term, which is nothing but your pi. The answer is pi. So this was asked. Can you remember? See this term. Evaluate this term. So this was asked. So we have found out now this term, which is nothing but your pi during the interval. Any doubt? So now we will go for the last problem. Find the Fourier transform of f of x equals 1, x is less than 1 and 0, x is greater than 1. So as usual, we will have to separate the terms and the limit goes, x lies between -1 and +1 as usual. So this will be your Fourier transform formula which you have written here. What are the limits? One is minus into plus infinity. The limits will minus infinity to 1, then -1 to +1, then +1 to infinity. As usual, this will become 0, this will become 0 because otherwise it is 0 within the limit. Now we will go for the second term alone, this term alone. So what is f of x is given as 1 here. So instead of f of x, you substitute 1 here. E power isx dx. E power isx can be expanded in terms of sine and cosine as I said earlier. So cos sx plus I sine sx. So instead of this, we are going to substitute here. So cos sx plus I sine sx dx. Okay. Now we are going to integrate separately. Integration of this term plus integration of this term. So now just tell me, what are this term? This is odd function or even function? This is odd function. So this will become 0. Immediately this will become 0. This is your even function. Even function means you have to write twice of this. So twice 0 to 1. -1 to +1. We have written in terms of twice 0 to 1. So cos sx dx. Is it okay? Cos this term alone. After integration you will get 2 sin sx by s 0 to 1. You substitute for x. So you will have 2 sin s by s. So this is your Fourier transform. Fourier transform of the function f of x. F of x is nothing but capital F of s. So we have found out now Fourier transform. Now we will go for inverse Fourier transform. So inverse Fourier transform, the formula goes like this. F of x equals 1 divided by 2 pi minus into plus infinity capital F of s e power minus isx dx. We have found out just now 2 sin s by s. So 2 sin s by s. You just expand. So that will give you cos sx minus I sin sx dx. Now you have to multiply, separate the terms. So we have multiplied and separate the terms as usual. Now tell me, what is even function or odd function? Sin s divided by s. It's even function or odd function? Tell me. This is correct. This is will be divided by s is s. So it's an even function. Very good. What are these sin sx? This one will be odd function. Odd multiplied by even will give you odd function. So that's why it is 0. Is it okay? Odd multiplied by even is nothing but odd. I repeat. See, sin s upon odd function divided by s will give you even function. So this term is even function. Multiplied by this term will be your odd function, because this is odd function. Odd function multiplied by even function will give you odd function. Answer is 0. So this term will not appear. So we have 2 sin s divided by s cos x dx. So as usual we will have to use x equal to 0 here. Can you remember? cos 0 is 1. You will have to use that interval 1, 0. So x equal to 0 condition you will have to use. So that will give you cos 0. Cos 0 is 1. So we have 2 to get cancelled. Okay. We will have 1 divided by pi sin s by s ds. Okay. 1 by pi is missing here. Okay. See, you have 2 to get cancelled. 1 by pi sin s by s. So this is for 1 by pi sin s by s ds. Is it okay? Now I have written in terms of odd function and even function. We will see. So instead of s you substitute minus s. So f of minus s sin of minus s divided by minus s. So we can write minus into plus infinity as twice of this. So we can write 2 times 0 to infinity. Because this is even function. Sin s by s is even function. So we have written in terms of 0 to infinity twice. Correct? Your sin s by s is even function. So that should be written 2 times. So 2 divided by pi. Putting now s equals x. You have ds by dx is equal to nothing but 1. So ds equal to dx. Putting s equal to x will give you ds equal to dx. Simple. So s becomes x. Your ds becomes dx. So 0 to infinity sin x by x dx is nothing but, we have found out now, it will come this side. So this will become pi by 2. The limit is 1 when mod x is less than 1, 0 when mod x is greater than 1. Okay, that's all. So we will see in the next class. So far we have seen few problems related to Fourier transform. Okay, Fourier transforms are very important. If there is any difficult problem, we can solve it. We can integrate, we can differentiate easily. So that's a technique that we have used in Fourier transform. Okay, so we will see in the next class. Bye students.